Hello. Hello.
Good morning, sir. We are just waiting for the other session chair to join the meeting, and then we will start.
Okay.
Yeah. All right. Good morning, everyone. Welcome to the session 3C, 3B. This is the second day of the conference, and we hope that it is as successful as it was yesterday. Might remind you, along with the technical sessions, there are keynote sessions going on parallelly. So after your presentation, if you want to join those, you are free to do that. However, please make sure that you are in the meet when we are approaching your presentation time. I will introduce and call upon the presenter before you can present. Since this session is recorded and is live on YouTube, please make sure that your video is on during your presentation. Only if there is a connectivity issue and you are intimated by the moderators, you may switch off your video. Other than that, you have 10 minutes in total to present and 5 minutes for Q&A. At the 8-minute mark, I will sound a buzzer, which would sound like this. You will hear this twice. And if you do exceed more than 2 minutes after that, I will try to warn you after that. Other than that, all the best. If the listeners have a question from the presenter during the presentation, please type that in the chat box, and the moderators will take it to the presenter during the Q&A time. If during the Q&A time you want to ask the question, you may either unmute yourself and ask, or you can again type it in the chat box. Please make sure before asking you raise your hand so that you can be called upon by the moderators. All right, so with this, we will start with the first presentation of paper number 252, Utilization of Reclaimed Asphalt Pavement, RAP, as granular sub-base material in road construction. The presentation is given by Mr. Guru Kalyan Biswal, and the paper is written in association with Mr. Sujit Kumar Pradhan. Sir, please share your slides and turn on your video.
Okay, madam. Thank you, madam. Sir, is this visible to all of you guys?
No, sir, your presentation is not visible here. Please share your screen.
I'm sharing that. Is this now visible, madam?
No, sir. We don't see anything shared from your computer. Please use the share button at the bottom of this meet.
Yes, sir. Yes, ma'am. Uh,
So if there is a connectivity issue, you may look into it and we will call upon you later, if that's okay.
Madam, now can it is visible? Is it visible?
No, sir, not yet.
Okay, madam.
Sir, I will ask our technical coordinator, Mr. Sahu, to contact you and help you with your connectivity. Meanwhile, we'll move on to the next
Okay, madam.
presenter. All right?
Okay, madam. Okay, madam.
Thank you, sir. Next presenter, Mr. Sumant Kumar P. Are you ready with your presentation?
Yeah, yes, madam. Good morning.
Okay. Dr. Sumant Kumar B will be presenting on experimental investigation on fly ash and GGBS based geopolymer corbels. So please share your slides and turn on your video.
Madam, you can see my presentation?
Yes, sir. Please move to slideshow
Yeah,
mode
yeah, that I
first so
can.
that. Sure.
Yes?
Yes, sir. It's fine.
Yeah. Yeah, good morning, everyone. I am Dr. Sumant Kumar, working as Assistant Professor at Kakatiya Institute of Technology and Science, Warangal, India. Here I'm here to present my research work, part of my research work, experimental investigation on fly ash and GGBS based geopolymer carbons. Coming to the introduction, as we know, cement production is involving a lot of virgin materials and also energy intensive process, and also it leads to a lot of carbon dioxide. That is, manufacturing of 1 ton of carbon ordinary Portland cement leads to releases 1 ton of carbon dioxide. So, and also as India is moving towards the infrastructure development, a lot of demand of cement has been increased. Coming to the waste byproducts, like waste byproducts from the thermal power plant, like fly ash, and also iron ore manufacturing unit like GGBS, are affecting our soil landfills. It is an indirect environmental problem. So using this waste byproducts and also reducing the cement, like using these byproducts as an alternative binders to the cement, which also have thermal efficient, low carbon print, structural stable, durable, and less expensive material. We are using these materials. Like several researchers have worked on the partial replacement of the cement and also the complete replacement. Partial replacement, we have a lot of research on it, and we have also have like pozzolanic like tertiary binary cements. And complete replacement, we have geopolymer concrete and also magnesium oxide. Coming to geopolymer concrete, it is used like silicon, aluminum, rich waste byproduct material like fly ash, GGBS, like triggering with catalytic liquid solution, which is a combination of alkaline hydroxide and silicate to form a source material. So geopolymers hardened forms amorphous structure where main emphasis on formation of cementitious material. Like hardening in GPC, OPC is due to hydration, whereas in GPC it is geopolymerization. Coming to the its mechanical properties, we know that geopolymer concrete have high compressive strength, high tensile strength, high bond strength, and also it's have high flexural strength. And also durability properties like chemical resistance, superior durable properties like chemical resistance, superior water properties, thermal resistance, fire resistance, thermal insulation properties, and fast strength development. In spite of these advantages, geopolymer concrete in practice is significantly limited because of lack of research in structural elements. So the use of geopolymer concrete as structural concrete calls for studies on its behavior on different structural actions such as compression, tension, flexure, shear. So it is mostly constrained as because earlier it was because of hot, what we say, uh, 60 degrees temperature curing was required, so it was constrained to the precast construction. And in precast construction, connectivity distress is witnessed in the region of well defined planes called as shear interfaces, where longitudinal shear stress may lead to sliding shear. So the examples for these are Kerbals and the bearing shoes. So the load carrying capacity of these Kerbals is analyzed by several theories like shear friction theory, like truss analogy, we call it as STM, that is strut time method. Like we have empirical methods, geometrical methods for force distribution, and the theory of plasticity. So different codes given their what we say shear capacities for Kerbals using shear friction theory, and numerous codes have given based on the strut time methods. A study on the shear strength of a monolithic interface of GGBS and fly ash based GPC on Kerbals has been carried out in the present investigation. Before going to the experimental work, the Kerbals are short bracket projecting from a column to transfer heavy loads from structural component. We have considered double Kerbals because here the Kerbals are projected from both the sides, because the main instead of single Kerbal, we have provided double Kerbal so that we can reduce the movement coming out at the interface section due to the application of vertical load with shear span, and hence to ensure that the interface failure will be happen due to shear only, not because of the other modes. Like we can see the failure criteria on the right hand side, the sketch. Coming to the different criteria for evaluating the shear capacity of the Kerbals, we have first shear friction, which is mainly because of three different mechanisms. That is because of cohesion, that which is because of aggregate or aggregate interlocking due to contribution of interlocking between the aggregate. Shear friction is because of the friction resistance depending on the degree of internal roughness which develops on the concrete surface across the interface. And the double action is nothing but the bending resistance offered by the reinforcement which is crossing the interface. That is, tension forces are induced in the steel, which is equal and opposite to the compression force between the concrete forces. When the load levels are at lower level, it is cohesion which is predominantly acting at the interface. And when the load levels are at high, then the crack forms at the interface, cohesion is broken, and it is mainly carried by the friction and the double action. Coming to the strut and tie model, few beams, like we have a beam region which obeys the Bernoulli's Bernoulli's equation, that is linear distribution, strain distribution, and there is also a distributed region, that is D regions, where the strain distribution is non-linear. So in these D regions, static discontinuities and abrupt changes in the cross section where the strain distribution is non-linear. So certain time model is simple and can be effectively used in the design of D regions. The complex flows of the forces in the D region are idealized as member of hypothesis stress in applying the strut time model. The tension is because of the reinforcement and the failure of the bar yielded. So the concrete may be crushed or compression may lead to the failure. These are the different and the code of practices where on the conventional concrete where the load carrying capacity of the reinforced carbons. Roth is based on the empirical approach. ACA has both approaches like shear friction and also strut and time model. CSA, that is Canadian code, is majorly predominant on the shear friction methodology, and PCI code is similar to ACI 318, and Hagberg is given his hypothesis on the strut and time model. European code is based on the strut and time model. Coming to my experimental program, we have cast around 15 Kerbals with M40 grade, 6 Kerbals with no shear reinforcement, 6 Kerbals with 2 number bars, that is 0.3% of reinforcement is crossing the interface, and 3 numbers of Kerbals with 3 number bars of 6 mm dia, that is 0.8% of reinforcement crossing the interface. The materials used are fly ash and GGBS as a binders, and the chemical composition is shown as in the table. Fine aggregate is confirmed to the zone 2 and reverse hand, and we have taken reverse hand. A coarse aggregate where the crushed granite or granite size and well graded. Potable water is taken for the preparation of the alkaline solution. We have taken sodium hydroxide solution of concentration 8 moles per liter, and the ratio between the sodium silicate to sodium hydroxide is 2.5. Mixed proportion is as per the table, and the left hand side sketch shows the our carbon dimensions, and right hand side is a failure criteria, bottom is the test setup. These are the ultimate shear forces and the stresses along the interface of GPC Kerbals, where the maximum shear force is noted, and also you can observe that the shear stress to the compressive stress is about 15%, and when the reinforcement is there, it is about 25%. And the result during the test, visible cracks are there, and we have found that the cracks are shear cracks associated with the crushing concrete at the intersection of the Kerbal and the column, and also provision of horizontal shearups may diagonal cracks propagate slowly towards the column Kerbal interface. And this was same flareal criteria was observed by the Roth and the Metok. And also we have seen that non-reinforcement samples, the cracks from supporting area has begun to emerge at about 65% of ultimate capacity, whereas reinforced concrete has developed at 45 degrees, so that we can understand that the sustained more loads, reinforced concrete, reinforced samples have sustained more loads, and horizontal shearups were sufficient to prevent. These are the comparative statement for different shear strength predicted by design codes, where we can see that these the average values are more than 1.5, which can conclude that the maximum load carrying capacity of geopolymer Kerbals increased as the compressive strength increases. Ultimate load on the Kerbals have been increased by increasing closed stirrup percentage, and also shear strength derived from the various codes and theories undervalues the shear capacity at the interface of reinforced GPC Kerbals and brackets. These are my references. Thank you for giving me the opportunity, JUIT and ICSMC. Thank you, madam.
Thank you very much, sir, for an insightful presentation. I would like the audience, if they have any questions. Are there any questions from the audience? Please unmute yourself and you can ask, sir.
Well, sir, I have a question.
Sir, good morning, sir.
Good morning, sir. So, did you perform experiments to find what you have presented?
Yes, sir. Yes, sir. Actually, we will just again I will present this thing. You can see the PPT, right, sir?
Yes, yes.
So we have performed the experiment on the geopolymer concrete, and these are the specimen. These are reinforcement where This is the main reinforcement, and these are the stirrups, sir.
Mm-hmm. Right.
And this is the test setup. We have taken the inverted, so that the this will be the what we say vertical load will be applied on the carbon at 8 by D as 0.5, 0.46, sir. And this is the crack pattern what we observed. This is the non-reinforced, and these are the stirrups. Wherever the stirrups are there, we got series of diagonal cracks, sir.
Mm-hmm.
And this is the what we say for M40 grade. These are the maximum shear forces at the interface. We got the shear force. So where 0.8% we got around 279, for 0.53% is around 215, sir. And
Mm-hmm.
without the shear reinforcement means main reinforcement will cross the interface, but no stirrups are there, sir, at the interface. That will be around 140, 140, 145. So it's around 0.17 means 0.17 times of your compressive strength, sir.
So how did you work it out? A maximum shear force at the interface.
So that we have applied the load, sir. There is a load cell
Okay.
we have applied. So total, suppose if it is around 230, it has failed. Initially, we have seen that no load was taken by the specimen. So 230 divided by 2. So P by 2, P by 2. So it will be around 115.
Okay. So what is the biggest advantage you see in, in using the geopolymer?
So that is what it fails in the similar pattern of ordinary Portland cement, but it has a superior compressive strength, superior durability aspect. So when we use the geopolymer concrete, you will be having more strength and also your and sustainable material. No, sir, we are using all waste byproducts.
Mm-hmm.
So we are going towards the reducing the global warming.
Okay, sir. All right, sir. Okay, okay. Thank you.
Thank you, sir.
Okay, I think Sugandha ma'am has left mistakenly. She will be joining soon.
Sir.
Well, is there any other question from the audience? Anyone wants to ask anything?
Sir, can I please?
Sure, sir.
Sir, for this experimentation work, M40 is used. So
Yes,
can
sir.
we use the same method for the lower grade concrete?
So this is only the part of my research I have done for M20, M60. So we got the same, almost same, what we say, failure criteria, but the percentage, like here we can see more than 1.5. There I got for M20 I got around 1.4, and for M60 I got around 1.8. The percentage.
Okay, sir. And which will be the targeted application area for the product?
So we can use replace the ordinary Portland cement.
Okay. Means this is not limited to only structural elements or like that.
No. It can be
Okay.
used. Now, if you see, the practically they are using for sleepers, for railways, these tracks, they are using for the sleepers. Why? Because in Australia, a lot of usage is there based on for geopolymer concrete. But still, it is limited in our Asian countries. But if you go to Australia, they use this geopolymer concrete up to 2-3 floors also.
Okay. Thank you, sir.
Thank you.
No, any other question from anyone?
Guru Kalyani, you may unmute.
Yeah, good morning. Pradhan sir, tell me, sir.
No. Okay, I am. No question, sir.
No.
Guru Kalyan, you may unmute and please try to share the screen.
Sir, can I share my screen to
Just
present?
share whether it is possible or not. Share the screen.
Okay. Yes, sir. Thank you, Suman sir. Now, yeah, please start presentation.
Thank you, sir.
Is it visible, sir?
Yeah, Biswal sir, you can
No.
rotate your mobile. Yeah, like this. Okay,
Chatting.
that's fine.
Sorry, sir. Actually, laptop is not working. That's why we are giving in
No,
mobile.
it's
Actually.
fine, sir. No issues. It is visible. Yeah.
Is it visible, sir? Right now.
Yes, sir. Yeah, Guru Kalyan sir, please start. Yes.
Good morning to all respected members and other participants. My name is Guru Kalyan Biswa. I am MTech scholar in IIIb. Today we are going to discuss about the utilization of reclaimed asphalt pavement as GSB material. This is the table of content that we are going to discuss. Then the introduction. So, as we know that India has a very long road network of nearly about 4 million kilometers, and majority of these roads are with BT pavements, which requires continuous regular maintenance work. All these activities, that construction and maintenance work, require a huge quantities of road construction materials, especially stone aggregates. However, availability of materials in our country is going decreased or limited. So this leads to the requirement of looking out for alternative construction materials. As there are many stage products available, but incidentally huge quantities of existing bituminous pavement materials are generally mined or removed during the resurfacing or rehabilitation or reconstruction operations. So that when these bituminous pavements are removed and processed, that becomes wrap, or we can say that reclaimed asphalt pavement material. This is basically coarse graded aggregates. Then the next is GSB layer. The in the GSB layer, it is basically the compacted layer immediate above the subgrade and immediate below the base layer. It has become it is used to solve basically three purposes. That is to transfer the loads uh, coming from the top layer to protect subgrade from overstressing and to serve as a drainage and filter layer. Then my objective of study is to uh, find the mechanical properties of materials and strength parameters such as OMC MDD and California bearing ratio values of new GSB mixes, that is the RAF with fresh aggregates. Then the materials we are using RAF, we collected RAF from near of our college, and fresh aggregate from plant area. This is the methodology. For this study we are using uh, this these mechanical properties to characterize the materials, and for strength parameters we are using OMC MDD and California bearing ratio. Then basically GSB layer is consisting of two layers. The first layer is to drain out the water which is coming from the top surface through cracks. That is, we say that drainage layer or upper base layer. And the second layer is to prevent the intrusion of subgrade soil to the subbase layer. That is separation of separation or filter layer. For this experimental study, we have used grade 3 as upper layer and grade 1 as lower layer or separation layer. This is the grading, general grading of grading 1 and grading 3 of subbase layer, that is prescribed by Morth. And here the gradation of aggregate which we have collected. This is the gradation graph of RAP and fresh aggregates, which shows that the both the metals cannot used alone for the construction operations, because these are not satisfies the most limitations. The proposition of GSB sample. The left hand side table shows individual testing mechanical properties test results of RAP aggregate and fresh aggregate. Both are found suitable for construction purposes. Both are in the limits of maximum limits, and the left hand side figure table shows that the the percentage of RAP we have used for the GSB preparation of GSB sample, that we have actually we have actually used 25% RAP by increasing up to 75% RAP. Then these are the mixed design of GSB grading 3 and mixed design of GSB grading 1 as per most classification. Then this is the physical properties of mixed gradation of grading 1, that is the filter layer. And from this table we can say that the test results indicates that the materials shows the good results when the RAP is 55% and the fresh aggregate is 45%. All the properties are showing the minimum values with compared to other proportions. Then this is the gradation physical properties of gradation 3, and the best result was at 55% of RAP and 45% of fresh aggregate. Then this is the modified Proctor test result for grading 3 and grading 1. This is again shows the good result for grading 3 at 55% RAP, and for grading 1 it is at 45% RAP. This is the severe value. We have performed soaked severe at 4 days and 7 days, and the values showing that the 4 days severe value for grading 3 it is coming to 34%, 186%, and for at 7 days it is coming 178%. So at 4 days it shows good results, and for grading 1 it is at 4 days it is showing to 34%, and for 7 days it is showing 154% at 55% RAP, and for grading 3 it is at 45% RAP. Then the conclusions showing that the dry density value of GSB mixes for grading 3 it is showing at 45% RAP, it is showing the best result, and for 55% for grading 1 it is at 55% RAP. Also for grading 3 we can use up to 75% RAP as the MDD value is higher than the natural aggregate value, even up to 75% RAP. Then the severe values for grading 3 and grading 1 45% and 55% respectively. These are some of my references. Thank you. Thank you, sir. Hello. Hello.
Yes. Okay, thank you. So, is there any question from the audience? Any question from the audience? Mr. Biswal, did you perform any durability experiments on this?
No, sir. Due to pandemic situation, we have not performed any durability operations. We have actually only performed the severe test and compaction test.
Okay. So, since it is reclaimed asphalt, so there must be some cost associated with it. I mean, to reclaim it. So, will it be economical? Do you think? I mean, will
Yes,
it be
sir.
worth the
It is.
effort?
Yes, sir. Because it minimizes the natural aggregates content and the uh, the processed the processing to segregation. So segregation process is not high as we compare. It can be easily uh, segregated by heating also.
Hmm.
So
So,
that's
what
why
is the
the
process of reclaiming? I mean, how do you reclaim the asphalt? No.
Sir, actually, we have collected from it is from a roadside, and then we have hit it up. Then
Mhm.
we just by a small machinery work
Yes.
from a nearby plant, we have just segregate it.
Mhm. So, it can be harmful for the environment because heating it up will produce a lot of pollution. Air pollution will
Yes,
be
sir.
caused.
Yes, sir.
So, is there anything that can be done from that angle?
Sorry, sir. This is a part of my research work actually. I
Right.
have not. Yeah.
Right. Okay, sir. Thank you. Is
Thank you,
there
sir.
any other question from the audience? Anyone wants to ask anything?
All right, sir. I think we can move on to the next presenter.
Okay.
Sir, ma'am, your voice is not quite audible.
Hello.
Yes, yes, ma'am.
I think we can move on to the next
Yes, yes.
presenter. Okay.
Sure, ma'am. Sure. Yes.
Thank you, sir. And so sorry
Thank you,
for the
sir.
presenters. I kept getting disconnected and for causing the trouble. I will call upon the next presenter of paper number 5, Mr. Vignesh R.
Yes, ma'am.
He will be presenting on reducing the embodied energy by selection of building components using generative software. So you may please present and switch on your camera.
Okay, ma'am. Good morning, everybody. So, is my voice clear and can you see the screen, ma'am? You can.
Yes, we can do that.
Okay. So, a very good morning to everybody. My name is Vignesh, and I am an assistant professor working in Sri Krishna College of Engineering and Technology, which is in Coimbatore, Tamil Nadu. And we have written a paper on reducing the embodied energy by selecting the building components using generative software. So my co-authors are Ram Praveen, Raman Sri, and Rogan. They couldn't make it, so I'm just going to present on their behalf. So these are the contents that I will be presenting today. It starts with an introduction, and then it moves on to the methodology, how I did the modeling in a generative software, the options that I've used for building components, the materials and the construction, how you do that inside the software, the zone settings, and then you also have something called Galapagos at the end, and then we will move on to the results and conclusion. So the main intention of doing this sorry yeah the main uh, intent for doing this is the greenhouse gases. So 45% of the greenhouse gases is from our industry, meaning the construction industry. So there are two types of energy which we use normally in buildings. One is the operational energy and the other one is embodied energy. So if you have listened to the introduction yesterday, Sir has said embodied energy. So this is a very new concept, not new, but it's new to a lot of people. So embodied energy is like the energy that you require to produce a product, something like a phone, something like your a pen, anything. You just require energy to manufacture the raw materials, and then you manufacture the product. So it requires some energy. That is called embodied energy. The operational energy is what we use inside a building, something like fans. We use energy for running the fans, lights, laptops, and everything. So operational energy and embodied energy are the two vital components when it comes to greenhouse gases. So several studies have dealt with the first energy component, which is the operational energy, but lesser number of studies have dealt with embodied energy. So this is a study which is purely based upon embodied energy. The intention of doing this is to identify a framework to select materials with least amount of embodied energy. That's the whole point of this study. You need a framework which is done inside a generative software like a grasshopper or rhinoceros. Even we can use Revit for this, but I used grasshopper for this, and I'm going to explain that. So embodied energy has to be reduced. That is the main intention of this study, and this is the methodology that I've used. I've initially constructed a very small shoebox model in rhinoceros, and then I have taken that into grasshopper, and I've given it some settings, something like how we use the space, something like conditioning the space, ventilation, how we utilize it. So all that will be given inside the second step. The third one is the main intention, the energy plus simulation. So everyone will know about energy simulations. Energy plus is a very big component in that. So Galapagos is used for selecting the best material out of all the options. This is the first one. This is the model that I've done inside Rhinoceros, which is software. Okay, so the dimensions that I've used is 6 for the width, 9 is for the length, and height is 3.25. Everything is in meters. I've given a very small model, and these are the components or the options that I've used for each component. So wall, if you see the first table, you can see that the wall components have 10 options, right? So this is all taken from a codal provision for Indian context. If you know something like ECBC, this is where I've taken it from. So Energy Conservation Building Code of India is where I've taken all these options from. So wall components will have 10 options, roof will have 9 options, floor will have 4 options. It doesn't mean these are the only options that is available in the Indian code. I've taken these options. So let's see how we can use all these things and get the embodied energy for each one of these components. So yeah, this is the embodied energy and embodied carbon. So as I said before, embodied energy is the energy that we require to produce a material. For example, if you take the first one, which is cement plaster, you require 1.5 megajoules of energy to produce 1 kg of cement plaster. Okay, that's the literal meaning of the first column. Okay. And the embodied carbon is the amount of carbon dioxide which is released into the atmosphere for producing this material. For example, for cement plaster, you will be emitting 0.3 kg of carbon dioxide for every kilogram of cement plaster that you manufacture. Okay, that's quite a lot. So similarly, all these other options will have the same values, embodied energy and embodied carbon. We've taken this from inventory of carbon and energy. This is from University of Bath. We also have a codal provision for India, and similar values can be taken from that one also. So the very first step is materials and component construction, how we give the software the inputs. So as I said in the last slide, you require all these steps to be, all these materials to be forming one particular component. And for doing that, we have used something like construction of an opaque material. And this is just the first material. For example, if I take the wall component, it has 3 layers. First one is a cement plaster, second is a brick, third one is a cement plaster again. So for constructing one material, you require the first picture. The three main inputs that you need to give are the conductivity, density, specific heat capacity. And apart from that, in this study, we have given an additional input like carbon, embodied carbon and embodied energy, like the first photo. So I said that it is having 3 layers. So you can give a layer option to combine all the materials into a construction. So as I was saying, this is just a framework that I am presenting, which will be giving you an embodied energy calculation. So as you see over here, this is the construction, and it has to be entered into the library. Okay, the zone settings. So this is also very, very important for any energy simulations. So the cooling set point is 26 degrees Celsius. So that means after this, it's just like your AC. So after switching on your AC, you set the AC to a particular temperature. So this is also similar to that step. 26 degrees Celsius. People density. So for every square meter, how much people will be inside the space and how much power they use for all the equipments. Lighting, how much light they use for their day-to-day work. There is no natural ventilation. I'm not given that over here in this particular study, but there are several studies that I have done which will include the natural ventilation and also scheduled ventilation also. Scheduling is like when you want to open the windows, it can be automated in this particular software. So as you see, these are the options that I've given. The first one are the loads, the conditioning, ventilation, and the settings. All right. So I'm combining all these things over here using the zone networker and energy plus inputs to get the model. Okay, and then I've given this option over here to run the whole thing. Okay, I've run the whole simulation using this parameter over here, and the constructions can be provided or can be included using the zone settings over here. Okay, you can see CONSTR, that's the construction. The other ones are loads, which are the people density, power density, lighting density, conditioning, the cooling set points that I've given. The ventilation options can also be provided. The main thing is the construction options that I've defined and I have provided over here. So after doing this, I need to get the best option for this, and I'm going to use Galapagos, which is also an inbuilt command, which will cross-reference all the options with one another. Okay, you can see some arrow-like arrangements over here, which is just the cross-referencing, which is done by the software to get the minimum embodied energy construction. So you can see over here, this is the construction which will be yielding the lesser amount of embodied energy. And these are the constructions which are given by Galapagos for walls, roofs, floors, and the embodied energy for the whole construction. 84.117 megajoules is the energy required for the whole construction. So in conclusion, the main thing that I noticed over here is that you can give all these values and you can find something like an embodied energy. But the thing is, you need materials which are high embodied energy materials also. You cannot just construct a whole 2-story building or 4-story building with just low embodied energy constructions. You need materials which will be supporting the low embodied energy materials. So if I say that I can just construct 4 stories with only mud, then that's not really good. It will not be durable at all. So I need some other materials like lime to strengthen the whole process. So in conclusion for this presentation, I will just say that the last step or the last sentence, natural materials have low energy, but you need a trade-off between the operational energy and an embodied energy. And also you need to integrate materials with higher carbon or embodied carbon and embodied energy to have a very good construction. We cannot just use low embodied materials. We also require higher embodied energy materials also to integrate and have a good construction with a better durability. Right. So that's it from my side. If very, I'm really thankful for your management for letting me present my work again. Thank you guys, and have a great day. If there are any queries, I will be happy to address them right now. Yes.
Thank you, Mr. Vignesh, for your presentation. Does anyone in the audience have any questions from him? Please ask. Unmute yourself and ask, or you can write it in the chat box.
The software which I've used over here is Grasshopper and Rhinoceros. So if you're really interested in doing this work, embodied energy and operational energy, this is the software to go to.
Okay. Anil sir, do you have any questions? All right. Mr. Vignesh, I
Yes.
wanted a little clarification on your presentation. You did this work. You've modeled different building components, and I'm guessing you've compared the embodied energy for all of
Yes.
them using the software, right?
Yes.
The
Yes.
shoebox model was having a model building, and then the
Yes, ma'am.
components that will be used in it. You compared the energy models.
Yes, ma'am.
But from your presentation, what I get is most of the work that you have shown us is a lot of it explaining the software that we already have. Can
Mm-mm.
you explain anything that is new that comes out of from your work?
I've provided a framework over here, ma'am. It's not that the software, it's not literally a step-by-step process. So you need to integrate 3 plugins along with the software to do this. So I've actually done a framework to get the embodied energy.
Okay, so this is a framework that you have either made, or in a way you have written in a way you have written a manual of how to get this, right?
Yeah, just a framework, ma'am. I've not written anything. Just a framework of how you can analyze something like this. That's it,
Okay,
ma'am.
all right. Okay, thank you. That's all was my question. Um, Anyone else has any question? Okay, thank you so much for presenting in timely manner. At this point, I will call upon the next presenter for paper number 99, Supriya Mahida. She will be presenting on eco-friendly use of waste thermocol in road construction and maintenance. Ma'am, are you ready?
Yes, ma'am. Yes, ma'am.
All right. Please start with your presentation.
Yeah.
Turn on your camera and share your presentation. Meanwhile, I like to remind you that the keynote sessions are going on parallelly. So if you want to join those, please, there are links available in the WhatsApp groups as well as emails you would have received.
I'm audible to all of you?
Yes,
Hello.
ma'am, you are
Yeah.
audible.
Yeah. Can I start?
Yes, ma'am, please start.
Okay. Very good morning, all of you. The topic for the presentation of an international conference on structures, materials, and construction is eco-friendly use of waste thermocol in road construction and maintenance. So the ID is 99. Myself, Supriya Mehra. I am a research scholar at IIT Ahmedabad. The co-authors of the paper are Dr. Yogesh U. Shah, Dr. Sangeeta, Dr. Prakash Mehta. So these are the following contents which we have used for the study, that is need of the study, aim of the study, materials and methodology, results and discussion, conclusion and then references. So the need of the study of the paper is that basically we have concentrate on the use of thermocol waste in binder. So to prepare the polystyrene modified binder. So the study is like that ki the production and consumption of thermocol is increasing worldwide, and it is expected that it will be increased around 15.68 million metric ton by the year of 2024. So due to the various applications of using thermocol in our routine life, and it turns into the waste garbage, and which creates the human and environmental problems. So this will be a leading challenge for the researchers and scientists, that how we use this waste thermocol and how to reduce or recycle it. So the to recycle it is a to reprocess it is a major problems, because it is having a very costly processing, so we need to reuse it. So we have find a solution that how we can incorporate this large amount of thermocol waste that we can use in our road construction applications. So here we have used waste thermocol to prepare this bituminous modified binder. So with this, we can use a large amount of thermocol, and parallelly also will have better pavement performance. So basically, the aim of this study is that to evaluate and compare these physical properties of the conventional bitumen and thermocol modified binder. So materials and methodology. So here we have used two kind of materials. The first is the conventional bitumen and second is the thermocol waste. So there are two grades we have used, that is VG10 and VG30. So VG10 is used for the colder region and VG30 is used for the warmer region. So we have procured these grades of bitumen from Tikitire Industries, which is located in Halol, that is in Vadodara, in state Gujarat. So we have performed some physical parameters like penetration test, absolute viscosity, kinematic viscosity, softening point, to see their criteria that it is matching or not. So as the table 1 shows the results of the various properties of these conventional bitumen grades, it suggested that they are falling in the specified limit as per the IS 73 2013. So thermocol waste, we have used thermocol waste that is also known as polystyrene, and it is falls in the plastomeric polymers, and which is produced by polymerization of the styrene monomer. The chemical formula is N times of C8H8, and its chemical structure is shown in figure 1. So we have used the packaging materials which was collected nearby the college campus, and we have seen these kind of waste near our garbage area on the roads or floating on the river side. So we can easily get this material at free, and there is no other you can just pay and get this waste. It is generally free of cost. Then after getting this, how we can incorporate this waste thermocol in bitumen. So we have having two different procedure. So first is like we directly use this thermocol in bitumen, and the second process suggests that we have turned this thermocol solid form in liquid. So first procedure describes that the small amount of pieces of thermocol, we just add in 500 gram of bitumen, and we just give the temperature of 150 degrees Celsius and mixed for 2 hours, and at the speed of 300 rpm to get a homogeneous mixture of thermocol modified binder. And the second process suggests that we just prepared a 50% solution by adding 50 gram of polystyrene at the same 50 gram of organic solvent which we have used, where we get a proper homogeneous mixture of 50% solution of thermocol. That thermocol solution we just add drop by drop in 500 gram of bitumen, and make it stirrer for the 2 hours for 400 speed at 150 degrees Celsius. The second procedure we have adopt VG30 grade, and the first procedure we have adopt VG10 grade of binder. So total there are 4 types of samples. Total sample, that is 2 conventional and 2 modified binders. So after having a proper homogeneous mixture of these two kinds of modified binder and conventional binder, we just gone through the physical parameters and find out what's happening after addition of thermocol in conventional bitumen. So first we have performed the penetration test. The procedure we have followed as per the IS code 1203. The penetration generally shows the hardening of the binder. So when we add 1% of thermocol in the conventional bitumen, either VG10 or 30, the penetration value decreases. That means the bitumen becomes harder after adding the thermocol waste. So that gives the proper hardening of the bitumen that will affect the strength. And the penetration test is performed with the help of penetrometer. Then we test the softening point. So softening point is generally we have proceed according to the IS 1205, which exactly says when at what temperature the binder will soften. So here when we add thermocol in conventional bitumen, the softening point gradually increases. Here it is increases a small amount. That means there is some property which at the temperature it resists to soften. So here because bitumen is a temperature susceptible material, we want harden and as at the same time we want softened material. So here the softening point is increasing after the adding of thermocol waste in the conventional binder. Then we have performed viscosity test. It is used with the help of Brookfield viscometer, and we have followed the ASTM D4402. The viscosity test is conducted in 150 degrees Celsius, and here we get that the viscosity of the binder, of the thermocol binder, is increased and compared to the conventional one. So at 150 degrees Celsius, the ease to mix the binder with aggregate for the further mixing for preparation with aggregates and uh, uh, with the modified mixtures. So here we can mix at the same temperature with the modified binder, and we have that ease of the binder to mixing. So the proper coating with aggregates that will be done at 150 degrees Celsius to have a very good composition of binder and aggregates at the same time. This is the fourth we have performed, that is rheological analysis. That is, we have proceeded with the ASTM D7175. So here figure 5 shows that G star by sin delta. So G star by sin delta is the rating parameter which we get from the dynamic shear rheometer. That is instrument which we just shear the small sample of the binder and it gives results as shown in figure 5. So with respect to every temperature, we have carried out the G star by sin delta value. The higher the G stars by sin delta value shows higher rating resistance. So we concluded from the figure 5 that the modified binder, that is VG10 plus 1% polystyrene and VG30 plus 1% polystyrene, shows the better rating resistance in the conventional binder. So whatever the drawbacks or limitations of the conventional binder, we can cover with modified binder. So here we can see that the green line gives us the higher rating resistance. That means VG30 plus 1% shows better rating resistance, which we generally seen during the cracks of the after laying of the bitumen. So basis on all these experiments results, it is concluded that the thermocol waste as a packaging material we have used is easily and effortlessly used for the road construction to improve the properties. And we have adopted the two procedures developed in the study, and it is both are suitable to prepare the modified binder. Based on that too, we have concluded that solvent-based procedure is more suitable as it is very easy to add, and it is uniformly distributed and gives us a better homogeneous thermocol modified binder. Then the use of this thermocol in road construction benefits the better the roads and utilize the waste, and it also resolves the problem of environmental pollution caused by this thermocol waste by using it for the road applications. These are the references we have used to study. Thank you, and thank you for giving me this opportunity to present my paper. Thank you.
Thank you, Ms. Maida. Anyone in the audience has a question on this very useful research these days with the increase in online shopping? We definitely do have a lot of thermocol waste.
I have one question, ma'am.
Yes, sir, please go ahead.
When bitumen is mixed with thermocol, how to ensure that the uniformity of blend is obtained actually?
Yes, sir.
How to ensure actually?
Yeah, sir. There is one there are two procedures. One is by code and one is by self-made. During mixing of, like I said, that 2-hour mixing is there. So to check that, we can just take a scale type of thing and we just dip it and take it out, we can see if there is some particle type stick on that plate, it will be non-uniform. If there will be a smooth surface stick on that scale type thing, then it will be uniform. And by code, there is a storage stability test, that is phase separation. There is small aluminum tube we need to keep for 72 hours, and we just need to find out its top and bottom softening points. If there is difference between more than 3 degree, then it will considered as a non-stable, and if the difference is less than the 3 degree Celsius, then it is considered as a better storage stability, that there is no phase difference between this top and bottom of the tubes. That is described in the storage stability code. And also it is mentioned in the IS 1654 code of the modified bitumen.
Okay, another question is that you have mentioned that the mixing temperature for VG10 and VG30 bitumen will be 150 degree. Okay.
Yes.
So for VG10, 150 degree will be more, I think so, because if you are using mixing temperature 150 degree, same for VG10 and VG30. For VG30 that is okay, but for VG10 the aging will be increased, I think. What is your point of view actually?
Yeah, sir. Generally, we have taken the if we modify the binder, code suggested you need to go nearly 180 to have that polymer to dissolve properly in the bitumen. So this is the plastomer is generally falls in the category of polystyrene falls in the category of plastomer. So plastomer is easily dissolved in bitumen at lesser temperature compared this to elastomer, which we majorly use SBS. So SBS needs 180 degree whether we mixed it VG10 or with VG30. So here first we have reduced the temperature up to 150, and for the conformity only we are taking 150 for this VG10. We can mix at 140, we can even mix with 130, but we need to check the properties. But for the optimum, we take the 150 degree Celsius, because after modifying process the binder becomes hard, so it needs a temperature to well mixed at that 150 degree Celsius.
Okay. As you have used to 1% of thermocol, and it is showing, I think, from the limited test, it is showing better results. So you may go through higher, means 2%, 3%, 4%. That will be better, I think.
Yes, sir. I after this study, I have also gone through the up to 4%, but after 4%, we need to add some cross linkers to go beyond 4%. So we don't need to add we don't want to go beyond 4, because the general adoption of this waste is optimum is 1 to 3. So we are just playing in that 1 to 3%, because after going beyond even 3%, we are having a phase separation problem. So if we again we need to go for higher percentage of the modifier, we again need some cross linkers, and that will directly the cost will be increased. And we want to prepare the modified bitumen with very cheap, very not much costly we want. And this is the thermocol we are adding is very free, like we can get we can get nearby our any residential place or any college or home or anywhere we will get. So we don't want to go for higher cost, because we can do by mixing any XYZ thing and we can prepare, but we are not going for that adoption. We need less mixing like XYZ and with cost comparison also. So that's why we are not going beyond. But yes, at my further research work, I have gone through 3% also.
Okay, thank you. Thank you.
Yeah, thank you. Thank you.
Thank you, sir, for your questions. Anyone else has question? Okay, Miss Maida, I was just wondering about the point that you just said about thermocol being available free.
Yes.
However, what do you think is the possibility of adopting this method in construction industry. Um, as in, for that, if on a large scale, if you need that kind of thermocol, that obviously will
Yes.
not be free. I mean, there's thermocol available in every household, but you need collectors and
Yes.
a logistics to collect it.
Yes.
Further, uh, if say I'm talking about a 1 kilometer stretch of road, just 1 kilometer, how much thermocol do you think you would need for construction? And let's say I'm not in transportation, but from what I see, a lot of NHAI constructions are on cement, are using cement roads. So have you tried to compare the benefits of your bitumen plus thermocol as
Yeah.
compared to cement road construction?
Okay, ma'am. The first thing is that key for you have heard about plastic roads. The plastic roads are generally due to that plastic roads. These whatever we are getting the material after preparation of plastic roads, that material are now costly, but these thermocol, many of them are not interested to adopt thermocol modified binder. But we have talked to some industries in this Ahmedabad area. They are given as free this thermocol, because the thermocol only, that polymer is like available in the foam. So if you want to take 10 gram of, or you want to store 10 gram of thermocol, you need a space. So that is the reason, the first thing I want to say, that people don't want to store thermocol because of its bulky nature. As compared to the other polymer, you can take 500 gram in a small tin. But if you want to take 500 gram of thermocol, you need a large space. So for that, we have adopt second procedure also. And we talk to this industry which produce polystyrene. They are giving us free. Till now they are giving us free, and they are telling us that they will be they will also help us to get this thermocol. So for that, and energy, if comes in energy consumption, so this if we compare with the other polymer, they are modified at height that I mentioned already at 180 degrees Celsius. Here we are preparing this at 150 degrees Celsius, so there is around 30-degree reduction. And the availability of the other this other polymers that are costly, and here you are getting free, or if is there is any charges, I don't think that it will be as much as the other polymers. Third is that this is, you can directly, there is no this is in use technology. You don't need any other technology, like any other instrument or any other thing to attach in your existing plant production. Whatever you are going with the routine life, you just need to add this polystyrene by any adopting method which I suggested. Just to ongoing plant production, you just need to add, and it will be smoothly following further.
Actually, thermal and fatigue criteria like mixing performance properties, it needs to be required. Otherwise, we can't get a conclusion that thermocol would be a better material. It may not be a cost effective. Means the research is going on. You have limited resource you have found actually. So we have to see the mixed proportion, like mixed properties like resilient mold loss, thermal
Yes,
cracking,
sir.
fatigue cracking.
Yes, sir.
Otherwise, we can't go because
Yes.
it is taking a large space, and if you hit a large amount of thermocol, then you will get just 50 gram or 20, 30 gram like that. And if you are constructing roads per kilometer or 500 meter, so it will require a large number of thermocols, large kilogram quantity.
Yes, sir. I want to just discuss something that for that the second procedure is useful, that you 50-50 solution is there, and you just have that liquid and add as it is. So there is there is no need of you need to store a large amount of thermocol. You just have that liquid solution that is of polystyrene, and just add drop by drop or that mechanism. But the second thing, that this the paper which I presented is limited, but on the other side I have carried out the job mix with this 1 2 3 4% of polystyrene, and we are getting very good results with the mixture also. With aggregate, there is a proper coating, there is a like a Marshall stability, then this direct tensile strength, modulus resilience, we have checked. So that is an ongoing, like we are working on that in mixing properties also.
All right. Thank you, Ms. Maida. You may stop presenting. I will call upon the next presenter of paper number 150. I don't know if I'm pronouncing the name correct. Miss Hosnia Jose. She will be presenting on an overview of the mixture design approaches for UHP FRC. Ma'am, please share your slides and start presenting.
Okay, ma'am. The screen is visible, ma'am?
Yes.
Okay, thank you, ma'am. Good morning, all of you. Myself, Josni Ajos. I am presenting a paper titled An Overview of the Mixture Design Approaches for UHP FRC, and my paper ID is 150. And this is the overview of my presentation. So moving on to the background of the study, we know that a nation depends upon the well-developed infrastructure. So the growing demands in the construction industry necessitates materials of higher strength as well as durability properties. And one such material is an advanced cement-based material which is known as the ultra-high performance fiber reinforced concrete, abbreviated as UHP FRC. So the preparation of UHPC with comparable performance under strict quality control and limited design guidelines have restricted its widespread usage. So in literature, most often the researchers have dealt with UHPC mixtures without much theoretical explanation. So this paper highlights the awareness of using UHPC to utilize all of its advantages, and along with suggesting all of the key factors for producing this material, also suggesting the best design method. So we can say that UHP FRC combines the properties of high performance concrete, self-compacting concrete, and fiber reinforced concrete. So compared to the metrics of conventional concrete, the UHP FRC metrics have a very tight microstructure, which gives it high strength, durability, as well as tensile ductility. So we can see a brief history on the development of UHP FRC. So with the introduction of superplasticizers in 1980s, the researchers were able to develop higher compressive strength, and with the inclusion of steel fibers in the late 1980s, the high strength matrix was aided with high ductility also. And as a result, compact reinforced concrete and slurry infiltrated fiber concrete was produced. And in 1990s, reactive powder concrete was also developed, and it has high compressive strength up to 800 megapascal, but the high production cost limited its widespread usage. And all of these led to the development of ultra-high performance fiber reinforced concrete in the 21st century. But the material demands high amount of cement content and also high curing procedures, and the development of the inclusion of supplementary cementitious materials in order to replace higher cement contents. Standard water curing has developed into an ecological and efficient ultra-high performance fiber reinforced concrete. And these are some of the case studies of the UHPC application. So what is basically this UHP FRC? We can say it's a combination of high strength concrete as well as fibers. It's a superplasticized concrete which is reinforced with fibers, and it has an improved homogeneity due to the absence of coarse aggregates. It has a characteristic compressive strength greater than 120 megapascal, higher tensile and flexural strength, modulus of elasticity comparable to that of concrete, and it has a lower water cement ratio less than 0.24. The metrics of UHP FRC consist of Portland cement, fine sand, supplementary cementitious materials, ductile fibers, and high-range water-reducing admixtures, specifically polycarboxylate ether-based superplasticizers, along with small amounts of water. So this is the weight range of mixed components of UHP FRC. As we said, it consists of higher cement content up to 1080 kg per meter cube. So these are some of the design principles which we need to consider while producing the UHP FRC mix. The very first one is the particle packing of the material components. So the UHPC matrix consists of a wide range of material classes so that every void gets subsequently filled in, and this promotes in attaining maximum packing density, which improves the strength of the material. So this is achieved by use of adequate particle packing models or ideal curves. And the second principle is the lower water binder ratio. We know that as the water binder ratio is decreased, the strength can be increased, and this is attained with sufficient workability with the help of high range water reducers. For a typical UHP-FRC mix, the water binder ratio ranges between 0.15 to 0.23. And the next point is the elimination of coarse aggregates in order to improve the homogeneity of the matrix. The particle size is less than 2 millimeter. So the aggregate size is proportional to the crack size. So in this mix, fine fillers are used. And not the least, the ductility. Steel fibers are usually included in the UHPC mix in order to improve the energy absorption capacity, and the fibers can bridge across the cracks and control their propagation. And moving on to the design approaches for the production of UHPC mix, the UHPC mix consists of multiple constituents. So the design, and because it consists of a lot of combinations of each particle constituent, so the design is a little bit difficult. So we have particle packing models, optimization curves, and statistical methods for the production of UHPC mix. And moving on to the particle packing models, it aims at achieving a maximum packing density considering the geometry, packing density, and particle size distribution of its individual constituents. So this method basically adopts a trial procedure in which different packing density combinations are worked out until a maximum packing density is attained. So there are basically three mixture models, and the very first one is the LPDM, linear packing density model, which was further developed into the solid suspension model, which uses the concept of virtual packing density. So virtual packing density, it is the maximum density which can be attained when each of the particle is placed one by one. And further development was using the compressible packing model, which considered the effect of which considered the process of compaction, which also influences the packing density of the mixture. So they have presented a term that is the compaction index, which accounts of the compaction effort. But all of these models, they deal with packing fraction of individual material components, that is, it can be sand or cement. They do not consider an integral particle size distribution. So the further development is using the optimization curves. They provide an integral particle size distribution, and this facilitates the inclusion of very fine components in the matrix. So they are continuously graded mixes which assumes all possible material classes to be present in the matrix. So this dates back to in 1907, where the Fuller curve was developed by Fuller and Thomson. They have found out that continuously graded mixes improves the quality of the developed material. So they have developed an equation, and further improvement was done by Andreasen and Anderson, where they have included a distribution modulus, that is here the Q term, which includes which defines the proportion of fine as well as coarse particles. So if the matrix is a coarse matrix, then adopt a Q value greater than 0.5, and for fine mixture, Q value less than 0.5 is adopted. And this Andreasen and Anderson model, they have considered the smallest particle to be infinitesimally small. But in practice, we know that the tiniest particle size even has a definite particle size. And this was introduced in the modified Andreasen and Anderson model, where D0, that is the minimum particle size, was also considered in the distribution. So for UHPC mixes, the Q value can be assumed to be between 0.22 to 0.25. And researchers have mostly used this modified and Andreessen and Anderson model for optimization of UHPC mixes. So this Andreessen model specifically acts as a target curve, and each of the combinations, that means different combinations of materials, are adjusted so as to form the mixture curve, that is the composed mix. And the deviation between this composed mix and target curve is being calculated using the least square method. And when this deviation is minimum, we can treat that mix as a best one. So different commercial computer programs, for example, EMA provided by Elcom, can be utilized for this purposes. But this method also has a disadvantage that a single distribution modulus is used to characterize the whole particle size distribution. And this can cause variations in grain sizes, because the grain sizes can be differing, and this the theoretically densest packing might not often lead to the maximum packing in actual case. So statistical methods were also developed, and this was based on the wet packing density. Why wet packing density? Because on addition of water to the mixture, lubrication and flocculation effect can take place. And by high range water reducers can cause a dispersion, and this can significantly influence the packing density of the matrix, especially in cases where the particles are finer than 100 micrometer. So a statistical method, that is a de-optimal design approach, is used for the mixed design of concrete. So this method involves a mathematical model where the response is being predicted by a number of variables. The response is the wet packing density, and variables are the individual material dosages. And the adequacy of this model is tested using the analysis of variance test. So therefore, considering all these, it is suggested that a combination of particle packing based on ideal curves to get the particle skeleton at first, and then followed by wet packing method, wherein the water binder ratio can be adjusted, and then obtaining maximum wet packing density. And this method can be considered for the production of an efficient Uhp Frc. Still, we know that Uhp Frc mixes, they require high cement content, that is around 1000 up to 1100 kilogram per meter cube. And the commercial mixes like maybe a Dura or a Ductal by Lafarge and all, they are 20 times more expensive than conventional concrete. And from this figure, we can see that the concrete industry is responsible for 8% of the global carbon dioxide emission. And from the graph also, we can see that it emits around 1,500 metric ton of carbon dioxide. So sustainability is indeed a pressing issue. So how can we achieve this sustainability in Uhp Frc? And that's by mix optimization and replacement of unhydrated cement by industrial byproducts. Since it contains a lower water cement ratio, so most of the cement will be unhydrated, and that can be effectively replaced by industrial byproducts like fly ash or GGBS or limestone powder. And these are some of the case studies where the cement is being replaced with a GGBS. So studies have found that about 20% of cement by volume could be replaced by GGBS. And the limestone powder was also used to produce UHPC with ultra low cement content, that is around 280 kilogram per meter cube, still achieving a compressive strength of 104 megapascal. Even the coarse aggregates were used to replace fine aggregates, and compressive strength greater than 150 megapascal with a 40% cost reduction was achieved. Also, efficient fiber application could be considered to attain a maximum wet packing density if the fiber content is about 2% by volume. So moving on to the conclusions from this study. So Uhpf Rc exhibits superior mechanical as well as durability properties. It demands proper selection of its raw materials, quality, and construction procedures. Also, the absence of widely accepted design procedures have hindered its widespread usage. And the main factors which are responsible for the production of this mix include optimum packing of its components, then mixture homogeneity, lower water to binder ratio, and ductility. Considering the design approaches, optimization curves are preferred to packing models due to their ability in incorporating very fine particle sizes in mixture, out of which a modified Anderson and Andreessen model is being extensively used to make optimum UHP FRC mixes. And it is suggested that the concept of wet packing density, along with the modified Anderson-Andreessen model, can significantly yield higher quality mixes. Nevertheless, sustainability should be considered. So, cement or aggregate replacements or low energy mixing and standard water curing could be adopted. And if all these manufacturing methods could be implemented, then UHPFRC definitely serves to be a powerful construction material. And these are some of the selected references. Thank you.
Thank you, Ms. Jules. Anyone in the audience has question? FRC is a very research topic these days. All right. Ms. Jules, you talked a lot about packing density, right?
Yes, ma'am.
So all I saw was all the mathematical models. Are there
Okay.
experiments done on it? And I'm curious to know,
Mhm.
are there any standardized um, tests to check the packing density? I mean, we can still find out density, but packing density, how densely a concrete has been packed, how do
Mhm.
we make sure that all the voids have been filled? That's a statement from one of your slides, right?
Ah. Okay, ma'am. Usually, researchers have used this modified Andreessen and Anderson model. So they will be fixing a value of distribution modulus so that they will be obtaining a target curve.
Right.
So individually, by trial and error method, we'll adjust all of the what proportions of each of the constituents in order to decrease this variation between the composed mix and target curve. So if this mixture curve properly matches the target curve with the least deviation, we can say that it's a properly compacted mix.
Yeah, but that is
In,
the theoretical part, right? Where you
uh,
do the mix design.
yes.
But what about the practical part, where how in real life you make sure that the packing density as proposed has been achieved?
Ma'am, that can be done by analyzing the wet packing density. That is, the wet packing method can be utilized where, like, we find the particle skeleton from the Andreessen model, and combining all these, like, we have what fixed a particle proportion using this Andreessen model, and using that we'll vary the water cement water binder ratio, and we'll
Okay.
ascertain the wet packing density by
Right.
varying the water cement ratio. And the mix which gives the higher packing density, we can consider it to be the best one.
Okay. But this is still part of mix design, the
Yes,
design part.
ma'am.
Uh, I'm still again curious about the
Mhm.
practical aspect of it. How on a site you make sure that it is happening what you have proposed, because always theory and practical is always different. There are always margins of error.
Mhm.
So how can a person on a construction site, professional
Mhm.
on a construction site,
Mhm.
make sure that you are achieving what you are proposing in the mixed design?
Ma'am, like we can, after the hardened concrete test have been conducted, like we'll get the compressive strength. So there are relations which relate the porosity as well as compressive strength. So from the porosity values, we can ensure like if it is sufficiently packed or not.
Okay, so you use the compressive strength test to do that,
Yes,
and check the porosity of the block.
yes, ma'am.
Okay, all right. Okay, okay. So how does a lot of what you talked about was UHPC.
Mhm.
How does fiber reinforce concrete? I mean, how does that further affect this? packing density? I mean, if I may have missed, I'm sorry about that, but
Mhm.
I saw a lot of discussion on UHPC.
Mhm.
But
Ma'am, fibers are okay. Uh,
are the same models applicable to fiber UHP FRC as well? That's what I
Yes,
want.
ma'am. Like the models have been aimed only at the dry ingredients, and afterwards, when we analyze the we'll be fixing a fiber content, and afterwards we'll be measuring the flow test everything. So in that way, we'll analyze that, and it is suggested that we'll keep to a fiber content of 2% by volume, so that will not affect much higher in packing density. Up to
Okay.
2% fiber, it's okay only.
Okay. All right. Any other questions from the audience? All right. Thank you, Miss Jose. It's Miss Jose. I'm
Thank you,
sorry
ma'am.
about mispronouncing your name.
It's okay, ma'am. Thank you, thank you.
You may stop presenting. At this point, I would like to call upon the next presenter, Mr. Pradeep Kuhar.
Okay.
Uh, he will
Thank you,
be
ma'am. Is
present.
I audible?
Yes, Mr.
Can I
Pradeep.
present?
Yes, please start presenting. Turn
Oh,
on
okay.
your video.
Okay.
Pradeep is presenting on heat enclave studies with impact on pavements in metropolitan cities. It's a review paper, and
Uh,
he has written this
my
paper
screen
with.
is visible.
Yes.
Okay, okay. First of all, good morning to the respected chairpersons and the authors present here. I am Pradeep Kuhad, a PhD scholar from JUIT Solan from second semester. First of all, I would like to thank ICSMC 2021 organizers, my supervisor, and the JP University to give me a platform to share my research and enhance my research skills. Today, my topic of presentation is heat enclave studies with impact on the pavement in metropolitan cities. So, in the overview, will have today in introduction part we have urban heat highland in the introduction as per the existing literature. Then we will discuss about the need of the study with specified objectives. After that, there will be discussion on the urban heat island causes and its impact. Then we will have detailed analysis of the classification of payments as per the existing literatures and their related research works regarding lowering their temperature, including the barriers of the cool payments. Then there will be concluding remarks followed by the current UHI mitigation measures. In introduction, first I would like to define the urban heat highland. The urban heat highland is defined as any urban area which has tendency to be warmer than a surrounding rural or lesser developed area. Today, every one of us feel that urban area are relatively warmer than surrounding rural area or undeveloped areas, and this effect is known as UHI, that is urban heat island. And the factors responsible for it is population growth, migration, rapid urbanization, and spatial expansion across the rural areas are the existing issue of concern to both developing and developed countries, as all these factors contribute to the UHI. Generally, UHI is observed in cities as these are the counter magnet centers for industrial activities, and then there will be a huge infrastructure requirements, which ultimately leads to Earth as a concrete jungle. In last couple of years, there is drastically enhancement in the usage of energy for cooling during the summers, and human beings are facing lots of respiratory diseases due to the increased air pollution and greenhouse gas emissions. And we there is also the water pollution is also there uh, due to the warmer runoff. Ultimately, it can be said that there is enhancement in the discomfort to the human life. According to the study by Seika et al. In 2012, there is about 7,421 deaths in the United States, as reported by the United States Centers for Disease Control and Prevention from 1979 to 1999. So it is the need of the Harvard to study the UHI and all the solutions to prevent it or to minimize its effects. So my motivation behind this study was to identify the best suitable material which will certainly reduce the UHI And also the authors want to address the different technologies and materials utilized till date in reducing the UHI in an organized manner. Now, coming to the UHI causes part, thorough study of the literature depicts that as the day progresses, a dome of warm air present over the urban area, and these areas are characterized to have more paved surfaces and concrete surfaces, which absorbs solar radiations during the day and enhances the surface temperature as well as air in contact with them. And then in the evening, high rise buildings form a canopy over the structures, preventing the heat loss to the upper atmosphere. In past few decades, uh, there is a decrement in the agricultural area with increase in built up area and also reduced area for water bodies. So all these land cover changes would certainly lead to UHI. Now these all causes have a drastically impact on the on us. After water, the most we know that after water the most consumable material in the world is concrete, and without it is not possible to have good infrastructure, and infrastructure is the backbone of any country. But too much concrete leads to UHI, by which we are certainly affected, as today we had compromised with health and comforts at the cost of infrastructure development. There are respiratory problems and mortalities from this increased temperature of environment. These are warmer. There are warmer days and nights with increased consumption of energy for cooling, which further leads to more pollution. And there is enhancement in the production of greenhouse gas at power plants in fulfilling the energy requirement of the city. Now come on the classification parts. In classification, I will describe the various types of payments and their related works in terms of mitigating the UHI. First of all, I would like to define the reflective payments. In past, to lower down the temperature absorption of payments, some work has been done in all types of payments, that is reflective payment, evaporative payment, and modified payments. If we talk about the reflective payments, then by increasing the albedo by 0.1, there is a decrement in approximately 5 to 6 degrees Celsius temperature, as indicated by the study in 2015. For this purpose, we can increase the reflectance of the surface by using light colored materials, and in the same direction, in 2009, it is desirable if a pavement surface has high reflectance at summertime but low reflectance in winter times. This all can be possible by utilizing a suitable thermochromic uh, pigments with adequate doses. These pigments can lower down the temperature 4 to 6 degrees Celsius in summer, and they can enhance the temperature by 2 to 3 degrees Celsius in winter. In the same direction, in 2020, a study was conducted, and it was identified that strength of concrete get reduced by adding these thermochromic pigments into the payments. Now, if we look about the evaporative payments, then porous, permeable, and previous and water retaining payments comes in the mind. Chen et al. In 2019 concluded that holes in the porous payment contain some moisture in it and dissipates the heat energy by evaporation of water and lowers down the temperature. In continuation of that, Ferrari et al. In 2020 added that permeable payment also utilized the latent heat of vaporizations. But in another study of 2011, and depicted that though the water can reduce temperature, but the roughness of this porous pavement uh, also reduces the albedo, which further reduces the reflectance. So it can be concluded that evaporative pavements only has cooling effects till they have access to water and they become dry as they absorb a high amount of heat during the due to poor reflectance. So we can also use water retentive fillers in concrete to cover this effect. In continuation, some modified payments are there, and we can use graphite powder. It has a better thermal conductivity, about 2 orders of magnitude higher than ordinary asphalt concrete. So it was added that asphalt pavement to form a pejorative resistive materials. Further study of 2019 stated that use of steel fiber in concrete can certainly enhance the thermal conductivity. We can also utilize phase changing materials. that are the substance which with a specific melting point and a high fusion heat and can store and release large amount of energy. As studied by Carlesi et al. In 2009, it founded that use of these PCMs can avoid fast temperature variations, that there is a decrease in amplitude of temperature variations. These are some barriers while constructing the all payments, whether it is reflective payments, whether it is modified payments or evaporative payments. Reflective payments may raise the surface temperature of nearby buildings during the summers, whereas evaporative payments are porous and thus have lower thermal inertia and low reflectance. So when dry, it is hotter and thus releases more sensible heat than conventional payment during the noon time. Similarly, permeable payments permeable concrete is less durable than dense concrete due to its high porosity. So heavy traffic, it is not usable for heavy traffic loads. Secondly, additional cost will be incurred in order to dislocate the clogging dirt in the cavity of the permeable or porous payments. Payment owners and manufacturers may view the use of cool payments as an additional cost and performance risk also. These are some technologies which are currently we are using or working on them to lower down the temperature of the payments. uh, First of all, if we will talk about reflective payments, then we can use high reflective white paints. We can use infrared reflective colored paints on the payment surfaces. We can cover aggregate with heat reflecting paints. Color changing paints are applied to the payment surface. If we talk about permeable payments, then use of steel byproducts can be there, as it increase the thermal conductivity of the payment. We can use blast furnace powder and water retaining asphalt. Uh, they can act as a filler and they can absorb moisture for more time. Adding fine textured previous mortar to previous concrete. Use of bottom mass and peat mass as previous concrete additives. In cool payments, the use of phase change materials can be there, and the use of environmental friendly materials we can use in the construction of the payments. So now coming to the concluding part, we can from the literature we had studied that there can be reduction of up to 20 degrees Celsius by changing the albedo of the payment. And reflective payments are best suited to warm summer season and open places that are exposed to the sun for lengthy period of time, whereas evaporative payments are better suited to wet, damp climates or where water availability is there. While selecting the type of pool payment, site-specific conditions should be thoroughly checked, and large-scale demonstration projects are urgently needed. Further, it is noted that very limited research work is there in adopting or utilizing any materials in the constructions, uh, especially the waste materials from the industry. Mm. And cost-effective technology should be developed to harness the heat energy absorbed by the payments. Some policies and guidelines should be formed at the center and state level in respect of further construction by keeping the UHI mitigation in mind. These are some references of my study. Thank you.
Thank you, Mr. Kuhar, for a very need of the hour presentation and research work. Um, Anyone from the audience has question from Mr. Pradeep? Okay, Mr. Kuhar, I have a question from your presentation.
Yes, ma'am.
As I mentioned before in the session, I am not into highway engineering.
Okay.
So there is a term that you use multiple times, albedo.
Yes, ma'am.
Can you explain what that term means?
Albedo denotes means reflectivity of anything, ma'am. If we increase the albedo, then it means we are increasing the reflectivity. If the payment that especially I want to talk about the concrete payments, because I want to work on in future in concrete payments. Then if we increase the albedo, then we certainly increasing the reflectance. And if we increase the reflectance, then the particular type of payment will absorb lesser temperature, lesser heat from the environment.
Okay, so it is going to reflect
Yes,
the
ma'am.
light. So is there something like a reflection angle at what it reflects, or it reflects as it comes? The angle of reflection is same as angle of incidence, something like that.
What, ma'am?
I'm asking the angle of reflection of light. Is
Yes,
it
ma'am.
same as like the path that light follows? Have you worked on that? Like how it comes and goes?
No, ma'am. Actually, I didn't work on this. Right.
Okay. I mean, I'm just curious to know if that reflecting part of the highway, does it is it reflected towards other structures, or is it reflected
Yes, ma'am.
back?
There are some studies which also suggest that if we only increase the enhance the reflectance of pavements only, then the that particular heat can be absorbed by the surrounding structures.
Okay.
So, ma'am,
So,
we have to develop a concrete that can be utilized as in pavement as well as in structures also,
okay. All
so
right.
that we can reflect maximum heat to the atmosphere.
Okay.
Like, ma'am.
All right. Any other questions from the audience? All right. Thank you, Mr. Kuhar.
Thank, thank you, ma'am, to give me the opportunity.
At this point, I will call on the next presenter of paper number 265, Ms. Lakshmi S. She will be presenting on damage detection in T-beam bridges using transmissibility of vibration signals. Ma'am, are you ready with your presentation?
Yes, ma'am. Am I audible, ma'am?
Yes, you are audible. Please start presenting and make sure to turn on your camera.
Good morning, everyone. Respected conference chairs and all other dignified speakers in this session. I am extremely thankful for this opportunity to present the paper titled Damage Detection in T-beam Bridges Using the Transmissibility of Vibration Signals in the ICSMC 2021, organized by the JUIT Waknaghat Department of Civil Engineering. Myself, Lakshmi S., along with my co-author, Assistant Professor M. Gayatri Devi, presents this paper here. Let me move on to the presentation. In this presentation, I would like to give an introduction to the topic and a brief introduction of the literature reviews that have been done, the objectives and scope of my work, the methodology that was carried out, the details of validation and the work that was carried out, and finally, the interpretation and conclusion of the results. Coming to the introduction, my area of research is actually in the field of structural health monitoring. This is a area that has very immense importance, especially in the present day scenario, where large number of structures are exposed to high level of damage, and catastrophic events have been occurring across the world. So better identification of the damage condition of the structure and early detection can be beneficial to avoid these unexpected failures. We know that damage occurs to a structure due to extreme loading conditions and when the material deteriorates over the pass of time or due to fatigue. So, damage in structure can be basically due to these reasons, and this damage can be identified using the structural health monitoring methods, basically classified as local and global methods. And most of the researchers have focused on identifying the damages in structures based on vibration methods, in which the structural vibrational responses, such as model parameters, natural frequency, etc., have been analyzed by the researchers, and based on a comparison of these parameters from the damaged and the undamaged model of the structure, we can come to a conclusion of the extent and location of the damage in the structure. So, in my study, I have adopted a parameter called transmissibility, which is an output only function, and it is defined as the response ratio between two locations on the structure. This response from the structure can be anything. It can be the acceleration or the angular velocity. And these are the two parameters that I have adopted in my study. And I will also look into a comparison between these two methods. So this is my literature review. From the extensive literature review, I was able to conclude that there are a large number of structural health monitoring methods that have been focused that have been carried out around the world, and many different methods have also been proposed. However, a research gap that I was able to identify was that in using this particular parameter called transmissibility, the studies have not been extensively carried out on complex and larger structures for detecting the damages. This is what I would like to attempt in this study. So that forms the objective of my work, to determine the damage index value of a T-beam bridge structure using the changes in the transmissibility of angular velocity, and also to compare that based on the transmissibility of acceleration. So that forms the methodology in which this study is basically a numerical study where a modeling and analysis of a bridge structure is carried out in the ANSYS software. And based on the results obtained from that and converting them into frequency-based domain in the MATLAB software, we were able to come to the concluding results. So this forms the validation of my work, for which I have used the reference of Al-Jalawi and Salam Rahmatullah, in which a small beam structure, a pin-ended steel beam, is used for their study. The beam dimensions are as shown in this presentation. And then they have adopted with going for a impulse point loading of 4.45 Newton per second at 0.127 meter from its right support. And they have carried out I have carried out a transient analysis in ANSYS workbench, and the acceleration responses at two selected nodes, as shown in this figure, A and B, have been determined. And this is the undamaged beam model. And secondly, a damaged beam model was created by inducing a 5% reduction in the Young's modulus value at this particular section shown here. So moving on to the details of my work, in this work, a steel T-beam bridge model of 20 meter span and 7.5 meter clear width for the slab deck is being adopted. There are three main girders at 2.5 meter center to center spacing and four cross girders at 4 meter center to center spacing, both having the dimension of 300 by 1600 mm, and an impact load of 10 kilonewton was applied at the midpoint of the slab deck. Then transient analysis was carried out, and the responses of acceleration and angular velocity from two nodes very much nearby to the point of application of the load, B and C, as shown in this figure, have been taken. And based on the results obtained from ANSYS, which are in time domain, then the conversion of these signals into frequency domain is carried out in the MATLAB software, and we were able to come to a concluding result of damage index using the expression shown here. So this is the bridge model and the undamaged model and the where in the Young's modulus value is given. So this result shows the acceleration value obtained from the two selected nodes. In this figure shows the time domain result, and the second one shows the power spectrum of the particular curve. And based on this graph, we can see that there is a maximum coherence between the two signals at a frequency of 15 Hertz, and the corresponding acceleration values were noted. Similarly, at 30 Hertz frequency also, we were able to obtain high coherence between the signals, and the corresponding acceleration values were noted. These are the angular velocity results so obtained, and in case of these angular velocity result also, the coherence was maximum at 15 Hertz, as shown in these two figures. The first one is for the damaged model, and this figure is for the undamaged model. So based on the obtained results of we were able to come to a conclusion that maximum coherence between the two signals from the two selected nodes were in the frequency range of 15 to 30 Hertz. So the corresponding transmissibility value based on acceleration, that is the ratio of acceleration from node 1 to node 2 at these particular frequencies were calculated. Similarly, angular velocity was also used for calculating the transmissibility value. Then, based on the transmissibility obtained, damage index from acceleration and damage index from angular velocity was calculated using the equation that was mentioned before in the slide. So we were able to come to a result that the average damage index was 0.006815 from acceleration, and that from angular velocity was 0.0371. So the obtained result was plotted in the form of a graph, and we can see that there is a higher value of damage index being shown by the angular velocity, whereas acceleration, the damage index calculated based on acceleration is having a very small indication only. So the higher the damage index value that is being shown by the angular velocity indicates that the obtained signals and the corresponding obtained results are very much strong and indicative also of the nature of the damage at that location, which cannot be very efficiently determined using the damage index calculated using acceleration. So we were able to conclude that the angular velocity based damage index calculated was almost 80% more accurate in localizing the damage than that calculated based on acceleration. And thus we were able to conclude that transmissibility based on angular velocity is a reliable function for detecting damages in structures and also in complex structures like bridges. So these are my references. Thank you.
Thank you, Ms. Lakshmi, for an insightful presentation and, of course, need of the hour because of extreme hazards that we are facing currently. Anyone from the audience has any question related to this research work? Okay, Ms. Lakshmi, I think you are aware of my comments on your paper. However, I am still confused on some of the terminology that you have used in your paper and the presentation. First of all, transmissibility. In theory, I mean, I'm not in structural health monitoring, but I am a structural dynamics major person. So as far as I know, transmissibility is the measure of how much acceleration is transmitted into the building from the ground motion as per physics. And otherwise, if you compare the static and dynamic displacement, that's a dynamic modification factor.
Yes.
Magnification factor, sorry. So I am again still confused about your definition of transmissibility here, because you define it as a ratio between two output signals or
Yes.
two signals, right?
Yes, ma'am.
So I am confused on that. Although because you are using acceleration as a parameter, I think that should be still fine. However, on angular velocity case, can you first define angular velocity for me?
Ma'am, angular velocity is actually at a particular location. It is by the extent of which how much the particular location will undergo a rotation um, in respect of time. That is actually the angular velocity value. It is also a more parameter based on vibration of the structure.
Okay, so you are detecting the rotation
Yes, ma'am.
of the beam at that particular location,
Yes, ma'am.
at the two locations,
Yes, ma'am.
and you are applying an impact load.
Yes, ma'am.
Okay, so the damage index that you are talking about,
Yes.
you say that from angular velocity you get a better parameter as compared to acceleration.
Yes, ma'am.
Can you figure out physically what is happening with the acceleration parameter? Why there is such a less detection of damage?
Ma'am, as far as I have understood from various literature studies, acceleration, when it is determined in actual on a field test on an actual model, then there will be differences due to the location of the sensor that is used to collect the signal. Because acceleration as a part of its orientation will measure gravity also, so there will be some associated error in it. So in coming to angular velocity, that can be avoided.
Um, I am curious on that because you are using high frequency as a parameter, right? Like you are detecting these at the high frequency. Can you show the slide where you show the coherence between the two signals? All right, here. So you are detecting a good coherence here
Yes, ma'am.
in at 30 hertz and 15 hertz, right?
Yes, ma'am.
But you are also detecting a good coherence at 10 hertz as well as 5 hertz. Why didn't you consider those frequencies?
Mm,
I mean, within the two signals, you can see a very close relation between those, right? So I want to understand the procedure of finding the coherence between the two signals here.
Ma'am, actually, coherence is calculated based on an expression, that is the ratio of square of cross spectral density to the product of the spectral density, auto spectral density from the two locations, and it was carried out in MATLAB. That particular operation was carried out, and we were able to come to a conclusion that at even though there is a similarity between these two signals at 15 and 10 hertz, etc., that is because they are having similar energy, but there is maximum coherence between these two signals at the 15 and 30 hertz frequency ranges.
So it is based on the coherence function that you have calculated.
Yes, ma'am. Yes, ma'am.
And but what are you trying to show from the graph then?
Ma'am, actually, from this graph, I would like to show that at the 30 hertz frequency, which was selected based on the coherence between the signals, the corresponding angular acceleration value as shown on this slide are 14 and 17.3, which we actually take for our calculation of transmissibility.
Yeah, but for from the time history, you can't really say that because you don't see what frequency that acceleration is occurring at, right? Or yeah, and those same accelerations are not reflected in power spectral density. Of course, they won't be. I mean, if you would have plotted, let's say, Fourier acceleration spectra, you would have seen that acceleration uh, at a particular frequency. So I'm confused on these plots. Like, why are you showing these plots at all?
Ma'am, I'm unable to find out. I'm not clear about your query, ma'am. Hello? Hello?
Hello?
Hello? Ma'am, am I audible?
Yeah. Sorry, I think I'm muted somehow. Okay, so I couldn't understand the significance of these plots because obviously from time history, you can't obviously tell the frequency, right?
No,
You
ma'am.
are calculating coherence from the power spectral density,
Yes.
right? So
Yes.
based on that, I can't understand why you're pointing out the acceleration on the time history here.
Ma'am, actually, from this is actually calculated based on signal analyzer app in MATLAB, where when we take the 15 hertz frequency values correspondingly, then the corresponding value at uh, for the acceleration versus time graph can be obtained here. So that was what I intended to show using this graph.
Okay. I mean, all right. I think that's either there is a miscommunication on how to do that, or I mean, the presentation here is not entirely intuitive to the audience. Um, the reason I ask this is because I am not sure. I've not conducted study on angular velocity. However, because you are using high frequency uh, to detect the coherence between the two signals, I don't know if you are aware, but at higher frequencies, a lot of vibration signals start to attenuate. And especially if there is a damage or crack, the displacement of high frequency signals is very low at higher frequency. So that high frequency doesn't propagate through cracks. It would be good if you try to look at it at a lower frequency, maybe then try to compare. That's one of my suggestions.
Mm.
That's not I'm not asking you to show that.
Yes,
I
ma'am.
think you're
Ma'am,
please
I
let
would like to mention one thing that here the sampling frequency is 100 hertz. That is, we are getting 100 signals in 1 second. And in such a way, we have plotted the corresponding power spectral density graph we have obtained.
okay.
So based on the values at different frequencies in the power spectral density, we have obtained the coherence values at different frequency ranges, and at this particular frequency we were able to find that there is maximum coherence, that is coherence value of 1, and at all other locations the coherence value is less than 1. So at
Okay.
that particular frequency value, it has been proposed in other researchers' study also regarding earlier studies of transmissibility, that this particular function of transmissibility possesses maximum energy at at the higher value of coherence. That is, at the value of coherence of 1, there will be maximum energy for the transmissibility signal. So in that way, we are actually coming to the frequency of 15 hertz and 30 hertz.
Okay. No, I got that procedure, but I'm doubtful when you actually do the experiment on it. You would get similar results, or you would be able to propagate, get a signal for acceleration at all. However, that is definitely for the future. But
Yes, ma'am. Actually, I am working on it on a research in the field and the actual study of field structures.
all right, all right. Thank you, Lakshmi. If there are any other questions from the audience, okay. Thank you, Lakshmi,
Thank you, ma'am.
for your presentation.
Thanks.
At this point, I will call upon the next presenter of paper number 123, Mr. S. Chaudhary. His presentation is on analysis of factors affecting construction labor productivity. All right, sir, you may start presenting. Sir, you are mute. Please unmute yourself.
Yeah, good afternoon, ma'am.
Good afternoon.
Good afternoon, respected chairs. I'm going to present my study on analysis of factors affecting construction labor productivity. This is my research topic, and I'm working under the guidance of Dr. Pankaj Bhangade, sir. My paper ID is 123. This is the flow of my presentation. Why it is required to improve the labor productivity? So there are three important reasons. So first reason is we can improve the uh, output in the same resources. Second important point is we can go for higher profit, which is the prime requirement of the organization. And third one, if the organizations are getting more profit, then they can invest in more projects. The last and very important point is that if the organizations are getting more profit, then there will be a possibility to give higher wages and better working conditions to the laborers. And the last one is this creates job creation. Now, as this is a very important point, that's why the central government has initiated some programs to award the best laborers who is having better productivity under the Shram Mantralaya. And in the previous year, 40 different laborers are awarded with the best laborers by Prime Minister Mr. Narendra Modi. So this is the overview of why it is required. Right now, there are nearly 1.5 crore unregistered workers are there in the construction industry, who are not getting benefits from the uh, schemes launched by central government. And this graph shows the need of development of high-rise buildings in the mega cities. Why I choose the high-rise building? Because in the mega cities there is a very high population density, and my research area is Mumbai city, where there is a density nearly 22,000 people per square kilometer, and those high-rise buildings are more cost effective, they are more ventilated, aesthetically good, they are sturdy, they requires very less land to accommodate more people, provide a large number of built up area, and also provides more amenities. So when we are considering high-rise buildings, so there are four different types of high-rise buildings are there. First is office building, then hotels, then residential and apartment buildings, and last one is the multi-purpose buildings. So my work is mainly focusing on the last 2 points, that is the residential apartments and multi-purpose building. Now, when we consider major areas associated with the construction of high-rise buildings, so there are six major areas. That is, first is a new technology, then labor force skill, then financial conditions of the client. Fourth one is the project location. Fifth one is the organization culture, and last and important is the facilities provided to the laborers. Now, all those six are major areas. Okay, my work is to analyze and evaluate the pinpoint areas which are required to be optimized to get good productivity. This slide contains problem statement in aim and objective for my work. As told earlier, it is necessary to go for high-rise buildings in the country like India, because we are having concentrated populations in cities, and the cities are expanding, and we are having very limited land. That's why it is required to move vertically. That's why my research area is to find out the factors affecting the labor productivity in the high-rise buildings. For that, I had set 5 different objectives. Now, in continuation with the literature survey, I'd surveyed nearly 58 papers from different countries, which include different projects. So the summary of the literature is given in the flow chart format, where those are the different types of projects which on which the papers are published, and those are the different methods which are used to analyze the labor productivity. Now, in my case, I had used MATLAB and relative important index for the work. Now, when I gone through the research papers, so I observed that there is a fluctuation in the participation uh, in the research work. So maximum participation is 384, and the participation or the involvement of the participant is purely based on their experience and the type of work they are doing. Then I had calculated the labor productivity for 2016 and 16-17 and 17-18 based on the data published by Indian government. Now this work is purely based on the statistics which are published by Indian government on their official website, and it was concluded that only in two states, that is the Gujarat and Maharashtra, we are getting high productivity, and other states are not consistently performing. So some reasons are observed in the reports which are published by the Indian government, so that we discussed in the further slides. Now when we are discussing about the research work carried out various researchers. So now it is required to see which type of methods adopted. So ideally, questionary is adopted by most of the researchers, so that is nearly 45%. And the SPSS software is used for the statistical analysis. But in my work, I'd adopted questionary for data collection, and I'd used MATLAB or a fuzzy logic for my further analysis. This is the fishbone diagram that I had prepared based on the literature survey, where a number of factors which are observed, which influence the labor productivity. None of the researcher has evaluated all those factors. They had predicted only the factors, okay, but I had evaluated those factors in my study. This is the research methodology that I had adopted. So first I'd carried out literature review, then I'd summarized the construction labor productivity data, then data collection I had done, then I had carried out data analysis, then preparation of model, and at the end, the conclusion of the study. So while collection of the data, I had adopted 4 different steps. So first step is related with the primary discussion with the laborers and staff to understand the issues at the site, because it is important to understand the issues, and to understand the issue, only discussion is the part. If we collect some data, and after that we analyze it, and based on the analysis we can predict something, but that is not a complete process, because laborers are uneducated people. So it is required to discuss their problem first, and then we can go for the further process. So first point is related with the discussion. Second one is to prepare primary questionary for pilot survey. So I had carried out it. Third step is to discuss the problem faced during the filling of the data with the laborers and the employees on the construction site, and at the end I had prepared a final questionary for collection of data from the various construction sites. So all those 4 steps are conducted to finalize the questionary. Okay, then this is the basic structure for the questionary. So the questionary is divided into 2 parts. First is the first part carry personal information, and second one is the research information. So personal information include gender, work experience, and weight, because some researchers has used this data for their analysis. And in the research information, it includes related to body pain, then body postures, job requirement, then work culture, safety, training, psychological factors, absenteeism, and medical facilities, because the last point is important, because now we are in the pandemic situation, and those numbers are showing the different types of questions that are included in the questionary, like 10, 5, and 15 related to that bit. So to finalize the sample size, I had used this Morgan table. So the sample size is finalized as 393, because maximum size is 384 in the table. So we can go for more than 384. So I had collected the samples for 393 different questionnaires from the sites. So after collection of that information in the form of questionnaire, I had prepared an Excel sheet, and then accumulated the data in the Excel sheet like this. After collection of the data, now it is required to validate that data. So for the validation, I had used Cronbach alpha test. So after using this test, I found that the value of the alpha is 0.9965. So that particular value lies in the excellent category. And for my satisfaction, also I had used the split half reliability test. So again, I had got the same value. So now it is confirmed that the data is validated, and it is in the excellent category. So now I'd use that data for my further analysis. So those are some images during data collection from the various construction sites. These particular images are during the discussion with the laborers, their supervisors and the engineers. Now I'd used a relative important index method to find out topmost 10 factors which affect labor productivity. So ideally there are total 47 factors are there in my questionary. So now I need to find out top 10 factors. So for that case, I'd use a relative important index. So in that particular method, I had calculated the rank for all those different factors in this particular fashion, and here I got rankings. So the rankings are obtained purely based on the responses given by the laborers on the construction site. So those are the different factors. So those factors are the topmost 10 factors which are ranked by the laborers, and this is the relative important index for all those factors. Now important point is that here wages is considered as the 10th rank by the laborers, means they are not interested in getting the wages. So if we see the other side of this particular case, laborers are getting good wages. So now they are interested in enhancing other points which are there from serial number 1 to 9. So I had prepared the first conceptual model. So all those are the 47 different factors that I had, 46 different factors that I had considered, and those are the top 10 factors which are evaluated based on the RII method, that is the relative important index method. Now all those 10 different factors now I had used for preparation of my model, that is my model number 2 in MATLAB by using fuzzy logic. So in the fuzzy logic, I had prepared rules. So those rules are more than 1300 rules. Okay, I had given that particular rules as input, and then I had calculated the output. So this is the graphical interface that I had used. I had used a Mamdani model for preparation of the rules. Now this is the output table from my model. Now when we observe this here, this 51, 52, 53, 54, those are the percentage input for the fuzzy logic, and x1 to x10, those are the factors which we had considered. Those are the top 10 factors evaluated by RII method. Now when we give 50% input for all those factors, we get the labor productivity as 89.4% only. Okay, when we give the input as 51% for all those factors, we get labor productivity as 89.7. Similarly, if we get the input as 54 and 55, we get a maximum productivity as 90.3, and the same productivity we are getting for 98, 99 and 100. Now the meaning of this particular thing is that for all those 10 factors, if we give the input as only 44%, then even we are getting maximum labor productivity. Okay, so for example, labor welfare, if we provide 100% welfare facilities to the laborers, then even we get 90.3, and if we provide only 55%, then even we are getting 90.3. So the conclusion based on this is that it is required to evaluate the different types of facilities provided by the client, and there has to restrict the things up to 55% to get a maximum, because if we are moving towards 100%, then expenses increases at the client side. So those are some screenshots from the MATLAB software.
Sir, you have exceeded the entire 15 minutes of your presentation time.
Yeah, just a minute, ma'am. I'm ending. So those are the surface plot, and I'm getting maximum output as 90.3 for 54, 55, and 56%. And this is the conclusion. So the conclusion is that the excess facilities provided to the laborers will not going to increase the productivity. So it is required to calculate the exact percentages. So through my research work, I had finalized, or I had evaluated this 54 and 55% as the uh, input for the labors. So those are the copyright and patent that I am having for my work. I had filed the provisional patent, and I am having 2 copyrights for my work. Thank you. Those are the references.
Thank you, sir, for an interesting presentation on labor productivity. Anyone from the audience has any question? Okay. Sir, I just had one or two questions
Yes, ma'am.
relative to productivity data that you presented. What are the factors, or how is the productivity calculated? And is there a reason, because a lot of laborers do go to Maharashtra and Gujarat for work. So is there a relation on migration of labor to the productivity data?
Yeah, ma'am. Actually, labor productivity is calculated for enhancing the input or enhancing the profit of the organization. That's why it is very important. And nowadays, all the projects are time bounded projects.
Right.
So it is required to focus on this bit, because laborers are in a migration process, and we are not educating laborers.
Right.
Yeah, that's why companies are not willingly invest money on the laborers. So so companies has to restrict their expenses in providing additional facilities. So how much facility is required to be provided, that is required to be evaluated. So in my research work, I had evaluated that particular number. So if we provide only 55%, then even we get a maximum productivity. So why to go for 100%? Because that is going to increase expenses towards the contractor or the client side. And the labor mentality is somewhat different than the employees. That's why it is very essential to find out that particular number. Those numbers may vary from site to site, or from region to region.
Okay. Right. Anyone else has any question? Okay. Thank you, sir. I
Thank you, ma'am.
believe there are presenters from yesterday's sessions. Paper number 370 and 218. Is any of the presenters here in the meeting? So which paper do you have?
370 ideally.
All right. So is it Mr. Arun Kumar? Or okay. Okay, sir, you may present your paper 370 on a comparative study of microsilica based concrete mix design using IS and DOE method. So please share your slide and proceed.
Yes, sir. Is it visible, ma'am?
Yes, sir, it is visible. Please go to the slideshow mode.
Good morning, everyone. My presentation on the topic is a comparative study of microsilica-based concrete using IS and the DOE method. The presentation includes the introduction part, the objective, material method, result part, the conclusion, and the references. First, we talk about the introduction. As we all know, concrete is a widely used construction material, and it is, if we talk about the worldwide, then it is the material which is used mostly. I think it is the material which is used worldwide more and more as the consumption increases in the, especially if we talk about the developed area or developed country, then it is the most material that we use. It is popular generally because it is durable, it is time-wise worker, it is easily available, and it is easily manufactured at the site also. That is why it is most of the time it is used. But if we talk about the history at the past, that we generally use the lime construction is lime is the material that we use in the construction, but with the development, concrete is the used generally. If we talk about the IS method, it is the basically the method that we use from the IS 10262 2009. It includes the basically the following step to find the target mean strength of the concrete, determine the water binder ratio, and determine the content from the curve for the cement microsilica, and determination of the desirable content of the superplasticizer, determination the proportion of the coarse and the fine aggregate. Then we about the DOE method, that is basically a British method. It works aggregate of the 600 micron. There are different parameters that we use in the DOE method. First, we took it determine the target mean strength, determination of the water cement ratio from the curve of the SP23 code, the cement content, then determine the wet density of the concrete, the quantity of the superplasticizer that we use. Okay, then determine the value of the aggregate, whether it is fine or whether it is coarse. Then HPC basically that we use design for the low water cement ratio to give the high strength, but low water cement ratio affect the workability of the concrete. For the making concrete more workable, superplasticizer are generally used now. Types of plasticizer is used as per the requirement. If we talk about the objective part, this study is based on the comparison of these two, basically the IS and the DOE method, British method, and then M50 grade concrete that we use for different percentage of the replacement of the cement with microsilica, that is 0, then 7.7%. We also find out the compressive strength for by the IS and the DOE method, and also the initial and the final setting time, also consistency. Also, the material we use is the aggregate fine coarse, the cement, and the superplasticizer polyhead 8100 and the microsilica. If we talk about the metallurgy, there are different tests that we use. That is the for consistency and the initial final and the compressive strength. That these are the tests that we use in the present study. And talk about the cement and the coarse aggregate, that is mentioned also the coarse aggregate, and the we use of the 10 mm, 20 mm, and the compressive strength is found out generally that we check only for two criteria, that is the 728 days. These are the material requirement as per the IS and the DOE method. In this slide, it is mentioned for the IS method. For the microsilica, these are the mixed design in the second part, lower part. This is for the DOE method, material requirement. Discussion part. As I mentioned, we done the replacement of the 0, 7.5 and the 10%, and that we have done on on the IS method, and then it compared with the DOE method. So this is the consistency test. As you show, as the percentage of the silica is increased, the consistency is also increased. This is for the initial and the final setting time. Initial setting time is decreases as we increase the microsilica content, but in case of final setting time, it does not gradually increase and decreases at the as you show. Initial setting time is largely increase in the high, but in setting time the decrement is not so high as you show in the initial setting time. Then compressive strength by the IS method. After the 7 and the 28 days concrete mix for the 0, 10.5 and the 10% replacement. As you show, after 7 days, 7.5 replacement gives 7.31% increment in the strength, and the 10% replacement also show 9.7 increment. And in the same way, for the 28 days, 7.5 replacement for and if our method shown for the 1 and the 20% increase for 7 replacement and for the 10 plus replacement it gives 7.54%. This is the comparison after the 7 days. For the 7.5 and it has 0.9 and 0.4 more compressive strength than IS method. It is for the 28 days compressive strength, both for the IS and the DOE method. In this also, at the 0% replacement, DOE method has 1.64 more strength and then IS method. And for the 7.5 and the 10%, DOE method show 1.6 and the 3.64% more strength as compared to the IS method. This is the conclusion part. I already mentioned in the graph for the 7 days and the 20 days how if we strength is as compared to IS strength is also increases. These are the references. Thank you. Hello, ma'am. Hello.
Hello, sir.
Hello, ma'am. I'm audible.
Yes, sir. Yes, sir.
I finished, ma'am.
No, yeah, sir. Is there any question from the audience? Rahul, sir? All right, sir. No questions from me also. I'm not an expert in this topic. Thank you for your presentation.
Thank you,
Uh,
ma'am. Thank you.
I don't think any other presenter is joining now. So, sir, if the other presenter joins, she can present in the next session, the last one. For now, you may stop recording the session for this session. Thank you, everyone. We have another session from 2 p.m. Please.